The rate at which you can write the same entity group is limited to one entity group write per second. And that seems, this developer's writing, it seems really low. They're imagining a Facebook application with 200,000 daily active users, which means something like 20,000 concurrent users on peak. So they're kind of contrasting this. They say, well, on the one hand, I have 20,000 concurrent users all making requests at the very same moment, and you're telling me 1 per second? Yeah. Where's the disconnect?
I think it depends on what your entity group was actually developed to represent and how extensive you've modeled it and the way you've modeled your data. If your entity group is really specific to the particular user that's making the call, then you won't really have to worry about it. 1 write per second will be perfectly adequate. But if you kind of sprawled it a bit and the entity group touches multiple users, then you're likely to have some contention on that entity group. And so you have multiple users banging away at it at the same time. So really it's best practices in modeling your entities that will actually avoid that kind of issue. So if you have 200,000 concurrent, 20,000 concurrent requests, you're likely to be accessing 20,000 different entity groups. You might have an issue. And
that should be fine. Yeah. You want to do 2 million concurrent users on 2 million different entity groups, that's absolutely fine.
Absolutely.
So, think about entity groups as, for the most part, your unit of transactionality.
Yeah.
So if you need some data related to a given user, like a user and their achievements, for example, and you have those stored in 3 or 4 different entities, you can put them all in one entity group. And then the App Engine data store will make sure that you can only have one transaction in flight at a time for that entity group. So generally what we see is that each user becomes an entity group, yeah, or each order in an order entry system, or each customer in a CRM system becomes an entity group. We actually also have, we didn't have this initially, but we introduced this again about a year ago, something called cross entity group transactions, or XG transactions. And that allows you to transact up to 5 different entity groups in a single transaction.
Oh, okay. Awesome.
So it used to be the case that, so before we had XG transactions, there was a little bit of this trade-off between I want to make my entity groups bigger because I want to do transactions, but I need to make them smaller to have the right throughput. And that was sometimes a challenge. There are, in fact, libraries that sprung up that try to figure out how to. The classic example is I have 2 bank accounts. I want to move $10 from this bank account to that bank account. I need to do that within a transaction. And if I deduct 10 here and then add 10 there and something goes wrong in the middle, the $10 has disappeared. Or if I add 10 first and then remove 10, I've created $10 out of nothing.
I like that one.
Yeah, well, let's do that one. With cross-entity group transactions, that's no longer a problem. You can actually, in a single transaction, make that change. So really, I think this is all about just structuring your data store in such a way that you do no more than one write per second. Another kind of a classic way that people run into this is they'll do something like they'll create a site counter. They want to know how many visitors came to the website.
Yeah. Exactly.
Favorite example, right? And so every time a user comes into the website, they increment the counter. Yeah. And this is what you would do in a SQL database. You would, kind of increment a particular row in the data store.
Yeah.
And the problem is only one person at a time can update that one record, because that one record is on disk somewhere, and there's some server responsible for it. And it can only touch that record, one transaction at a time, and that's really limiting for the number of things you can count. And so, a typical strategy that you use for the App Engine data store is to create something called a sharding counter, sharded counter,
right,
where you partition the counter into multiple counters. So, instead of say one counter, you split it out and you say, okay, let's make 5 counters or 50, some number n that's configurable. And now every time someone comes to the website, I'm going to, at random, pick a number from 1 to 5, and then I'm going to update that counter. So say it's counter 3 this time. The next visitor comes in, oh, it's again counter 3. Oh, now it's counter 2. And you say, well, that's weird, because now your total page view count is split up around 5 different counters. But that's not a big deal, because you can easily select 5 numbers and add them together. This is a very easy task for a computer to do.
Yeah.
But by doing so, you've just increased the throughput of your web counter 5-fold. Right. If you need 50 transactions per second, you go 50-fold, plus a little bit buffer, so maybe you go 60, something like that. But it's very easy to shard your counter out as far as you need to go.
There's actually examples on the website, isn't it?
Yeah,
In
it's
the
our
development documentation.
article. Yeah. So with a little bit of data modeling, you can do as many concurrent users as you like, and hopefully you do a lot more than 20,000. But 20,000 is pretty awesome. I wish my website had
20,000 is pretty good, yeah. And well, I guess the message here really is avoid shared mutable state. I love shared mutable state as a saying. Every time you share state that's mutable, you're going to run into problems with concurrency. So just keep it isolated. And
if you do that, you're going to have a bad time.
You can have a bad time, absolutely.